Dear God in heaven, we are grateful for another day. Thank you for bringing us together under this umbrella to study. We ask for understanding. We ask for clarity. Let everything we'll be going through today, Father, be a moment of reflection indeed. Help us as we prepare for our examination, and at the end of it all, we will all have focus to glorify your holy name. In Jesus' name, our prayers are answered. Amen.
Amen.
So I believe we can hear me. We're looking at the first topic, which is set and subset. We'll take it. I want to just take it like bit by bit, as if I've not taught it before, so that all of us can understand and be on the same page. I prepare slides for the class the day I taught it. So occasionally I'll be going to them as well. I have a whiteboard with me just in case I need to manipulate some things. There's any need for any working. Okay, but the main focus will be the course material. That will be the main focus of the meeting, since we are preparing for examination, and of course, they'll be picking the questions from the course material. So maybe in subsequent classes, we'll take a look at the summaries and the past question we have in our summary club, and then I'll see possible questions that could come from any of these topics that we are treating, and then position ourselves to handle them. And as we're going through it, if there's any question we saw in our TMA, okay, that is connected to what we are doing, we can also pay lip service to them. Okay. So at this point, I think we can fire on. If you look at the course matter, you will see that they talk about sets, like define sets holistically, explain what notation is all about, finite and infinite sets. Okay, I cannot be heard. Hello?
No, I can hear you. No, that was
Okay,
before.
okay, so we have equalities of sets. We have null set as well, proper subset,
comparability.
yes,
Sets of sets.
okay, we have proper subset. We have comparability. Yes, comparability of sets. We have universal set, power set, disjoint set, etc. Okay. Then there is another thing here, which is okay. So that is that for that. Now, introduction. The theory of set lies at the foundation of mathematics. Hello?
I can hear you very well.
Okay, the theory of sets lies at the foundation of mathematics. It is a concept that rears its head in almost all fields of mathematics, pure and applied. The unit aims at introducing basic concepts that will be explained further in subsequent units. There will be definition of terms and lots of examples and exercises to help you as you go along. Now we have set, okay? What is set? So they say that, as mentioned in the introduction, a fundamental concept, so they say that, as mentioned in this introduction, a fundamental concept in all a branch of mathematics is that of set. So when we say fundamental, it is a foundational. That is what they are trying to say. Okay, mathematics is set. Now, a set is any well-defined list, collection, or class of objects. The object as we shall see from the examples can be anything, but for clarity, we will list 10 particular examples. And then when you look at them, there are two particular styles to denoting sets being mentioned here, which we see after looking at the examples. We have this one is an example of a set. The numbers 0, 1, 2, 4, 0, 2, 4, 6, 8. We have solutions to the equation x squared plus 2x plus 1 is equals to 0. This is a kind of equation you call quadratic equation. Okay, those of us that joined on Saturday when I was teaching mathematics, that was the topic we dealt with. So you can see that that topic will come because that is through that method we are going to use to solve this equation to get the answer. Because normally, if they give you something like this, you need to solve it to know what will be the actual element, as in something like this. Then we have the vowels of the alphabet A, E, I, O, U. And then people living on Earth is a set. Okay, people living on Earth, set. Because you can mention them one after the other, even though we are many. Okay, we have students, Tom, Dick, and Harry. All right, and I have another example. The students who are absent from school is a set. Okay, set of students absent from school. Could be any schools actually. Okay, the countries England, France, Denmark is a set. And we have capital cities of Nigeria. All right. Then numbers 1, 2, 1, 3, 7, and 10, rivers in Nigeria. All these are set. And the set here that what you should know that the set is in the odd numbers. That means like this one now, 1.9 is odd number. They are defined. That is, they are presented by actually listing its members. Look at it now. 1, 3, 7, 10. We know the members already. See this one again. The students, Tom, Dick, and Harry, they are mentioned, so you know them. See this, and then the vowels, A, E, I, O, U, they are what's listed. So if you check, you'll see that these ones are defined. So when we say a set is defined, it means that the members are listed. And then the set in even are defined, they are defined by presenting or by listing his members. This other one is defined by stating properties. So you can actually define set in two ways. Okay, you can define by listing, I can define by stating the rules. Okay, the rules or properties. So you can see here rivers in Nigeria. They don't tell us that river this, river that, but we know that as far as you are a river in Nigeria, you are qualified to be in this set. Okay. And then after that, they talk about hello.
I can hear you.
Yes, we can hear you.
Then we have okay, so they said this one, the students who are absent from school. So we don't know who and who, but if you are actually absent, definitely you know they're talking to you. Capital cities of Nigeria, they don't tell us what and what city. But if any city is a capital city, it's qualified to be there. And then we have the numbers 0, 2, 4, 6, blah 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 blah. This one is for the other one defined by what listing. This second one, the solution. So we don't know this. We don't know the numbers or the element. Okay, but by the time we solve this particular property, this equation, you will get to have your answer. Okay. I had a class on that on Saturday. I'll conclude this Saturday. Quadratic equation. The link to that class is on my YouTube channel, and we can go there and watch if we actually want to understand the quadratic equation. I don't think they listed it as a topic in our course material, but there are many topics that you will have to deal with. And if you don't have that understanding, you may not be able to overcome. Okay, so that is that on that. Let's take a detour through some of the slides I prepared. Think this one. So you can see here, set is any well-defined list, collection or class of objects. So you can see the sets that are being defined by listing their members. I separated them, that is these 5, and then see the one that is being defined by stating the properties. You can see them. So at this point, there was not much work on me then. I had time to do all this one, but now, so much work. So we have a method of set notation. So we have first the statement method, which was not identified, it was not stated in the course material. So the statement method, here, a set is denoted by brief sentence describing the common property. We have defining the set of the elements. So you use a brief sentence, okay, describing the common properties. Common properties are things that are in common to all the elements, okay, all the elements in that particular, all elements, okay, all the elements in that set, what they share in common. That is what I'm looking at. So use a sentence to express it, and you must not forget this must be within a curly bracket. Okay, within a curly bracket. Please, am I loud enough?
Yes, please.
Can you hear me?
Yes.
Okay. And I hope you are understanding.
Yes, boss, I can hear.
Okay, thank you.
I am.
So some people, I can see is like can enter link blah blah blah. So I think some people are having issues, and their best bet will be the replay. So let's move on. Now the set of in our solar system is noted by what? So what as is the statement method, you will do it this way. Write that statement. So planet in our solar system, enclosed in a curly bracket. Okay. And then we have the set of BRICS nation, denoted by what? BRIC nations, and curly bracket. So this BRIC is Brazil, Russia, I think China, and South Africa. So they are the ones that you call the BRIC nations. Okay. So that's on that. Then the set of colors of rainbow is noted as the colors of the rainbow. Hello, are we there?
Yes, sir.
Yes.
All right. So there's nothing much here, just for you to just write the statement. The statement that actually shows the binding properties of all the elements in that particular set, and then close it in your curly brackets, which is also known as braces. So we have a question, set of question here. We say, write in statement form a set of students in class 5 whose weight are more than 5 kg. What is it going to look like?
It's going to be a statement. It's going to be in a curly bracket. Students whose weights are more than 50 kg.
Okay, so they said a set of students in class 5 should be students in class 5. whose weight are more than 50 kg.
Curly bracket.
Okay, that's what. Yes. Then, so it said a set of numbers greater than 65 and less than 100.
So to be curly brackets, numbers greater than 65 and less than 100. You now use the greater than sign and less than sign, right?
No, it said
Oh, I think.
numbers greater than 65. You just use a
But the,
statement. You don't have in this one. You are writing in words. You don't
all
have to
right,
observe any symbol, mathematical symbol.
all
Okay,
right, I
so
get
we
you.
get to that one later. So
So
this
in the
one
okay, you just
is
write
just for you
in
to write
words.
it statement in English. Yes, you
Oh,
can see.
yes.
You don't use any mathematical symbol here.
All right. Okay.
Then a set of footballers. It should be a set of football players between 22 years to 30 years old.
So it will be
So this will be
football
what
players
football
between
players
22 years to 30
between
years old, enclosed in the brace, which
yes,
is the curly bracket.
yes. So that one. Then we now have the rooster. The second one is now the rooster or the tabular form. This is where the course material now starts um its own provision. So so we go. They said here sets will usually be denoted by capital letters, of course. So if you have something like this, let me write here. If you have something like this, oh my God. Okay, okay. Let me just say you have A. So you can now have A, B, C. So this one in capital letter is like the name of the what
The
set.
set
Okay. Why all these ones?
are its members.
Okay, they are the what the element. Yes, they are the elements of this set. So you use capital letters to name to denote that this is
So
a
you know,
set, and then the small letters you usually contain the elements as the members of that set. I don't know if you understand. If I
yes,
say the boss study group and tutorials, that is the name of the set. I can denote it with A. Then the members, okay, Mrs. Evelyn, Mrs. Moturayo, Mrs. Victoria, Mr. Sonny, Miss Happiness, all those people. So that's the members. So people or things, depending on the nature of the set that you now find. So these ones now are the elements, which are also known as the members. Okay, you denote them with small letter, no need of capital letter, so as to avoid confusion. You know one thing about mathematics is a very organized discipline. Okay. Hello, are we there?
yes, sir.
Yes.
All right, so let's keep going. Don't mind me or distraction everywhere. Phone calls are coming in, and I need to be, replying them on message that I'm busy now. Okay, so we can see this capital letter set. So lower cases will represent elements, just as I explained already. Now let's take an example. If we denote a particular set by actually listing its members, for example, let A consist of 1, 3, 7, and 10. Then we write A is equals to, and then hold on, I'm coming. Please. Hello. Hello?
Hi.
Okay, one of my neighbors, he needs something. I've discharged him temporarily. He might come back later because we're not yet done. So let me continue with my class anyways. So we're looking at, it said here that A consists of 1, 3, 7, and 10. Then we'll write it as this. Okay, so the elements will be inside and they must be separated by commas. Okay, and then after being separated by comma, you enclose them within the curly bracket. And that is the elements are separated by commas and enclosed, so that is just that. And we call this the tabular form. You remember that here we are dealing with the rooster or tabular form of denoting sets. Okay, all right. So now we have an example. I have an example. It says state in words and then write in tabular form. State in words and then write in tabular form. So it says solution. Now it reads A is the set of x such that x squared equals 4. Now the only numbers which then squared gives 4 are 2 and minus 2. So this will be the set. I'm going to explain that again. Hello?
Sir,
Hello?
I can hear you.
Okay. So they said here, they said state in words and then write in tabular form. Already, you know what is tabular form? Tabular form means something like this. Okay. When you enclose the elements of the set within a bracket and then separate by what? By
Commas.
commas. Okay. So let me. So that means that what they expect from you is to solve. Like you're going to solve those. Hello.
I can hear you.
Okay. So you have to enclose. Your answer um in a curly bracket. So that means if it's something you need to solve, you first deal with that. Okay. So they told us that we should write in words and then write in tabular form. Okay. So they said there, you need for you to that writing in words will help you to interpret. Okay. To help you
And
to
that
interpret.
has to be the statement, right?
Yes, it be a statement, but it's not like the question is not asking you to express in statement form.
To
It's a
say
tabular form, so the statement will just be there. But if it's a statement form of expressing a set, you will enclose in curly bracket as well. Okay,
yes.
so they say they know this x. So this what this means is um this X is an element of A. They don't even do it very well. This bracket is not supposed to be there. This side
Ah,
of the bracket. So it should be X is an element of A such that X square is equals to 4. Even this square, this one is not here. There's a mistake there. Let me see if I corrected all that. Okay, this one I use different examples altogether. All right, so let's just deal with that one first before coming to my own. So then you have x is an element of A such that x squared is equals to 4. Let's see what they said here. So A is the set of x. Okay, so A is the set of x. It's also the same thing as saying that x is element of A. I don't know if you understand.
yes.
You can say yes, X is an element of A, means that A is a set of X. That means set of
A is
A
the name
is
of
a set of X. That means every element of A is represented as X. Do you agree? Get the whole thing? If I say A is a set of, okay, fine, A is a set of married women in Nigeria.
Okay, so hold on first, boss. A is
Hello,
I can hear you. A is a set of married women, okay?
who is there?
I can
Okay,
hear you.
a minute. Yes, in so now say that yes, if don't now if married women is represented by X, you know that married woman could be any of the women that are married in Nigeria. So if I say I can say that what X is a what is an element of married women. So that married woman represented by A, that let's say you as an example, you are an element of married women. Okay, then married women is a what? And then that A is a set of married women. Like a set means it is covering all of you. All right. Then an element means that you are part of the set. Is that clear?
Yes.
When I come, I am back. All right, so he's gone. He wants to just help me to get some stuffs. You know, this is because of my work. I'm not that mobile that much again. I have to. So people are helping me to do things. So that's just it. He's fine. I've settled him. So I'm expecting when he's done, he will get back to me on how far he has completed the task I gave him. Okay, good. So I was trying to explain something. Please, I don't know if I am making it a bit complex for us.
No. I get
It
it
said
now.
yes,
A
yes.
A is a set of married women, and X is the element of A.
Yes, so that element means member. So if we say married women now, okay,
Yes.
you are part of them. So that means in that context, you are part of the X. The X
Yes.
is not just like X is representing everything there. So that X now, no, you know, in we are doing equation. Okay, we are doing equation. We always have an unknown value. We always
Yes.
have unknown value. That is the one that it varies. If we say now x plus 2 is equals to 10. So that x is representing a number. So in this case, x can be anything. Okay, if elements of A turns out to be 1, 2, 3, 4, 5. All of them are X. So X is a variable. That's how they explain it. So just trying to give every one of you that is a married woman that name X. Okay. Then that is at the individual level. Yes. But generally, as a set, the name of the set is being presented by A. So in that context, if I say a set of married women, it will mean what? It means A. I'm talking about A now. In this context, it's A. Then if I now say members of set A,
individuals of that A.
Yes, individuals that is the X. Do you understand? So the X will be in the enclosed bracket. The A will be outside as the name. So in this case now, married women, Mrs. Thompson, Mrs. Ade, Mrs. All of them are all married. So they'll be in the enclosed bracket, comma, 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 comma. They are the X. Then the married women, okay, maybe I don't want to write married women in full because of space. I use A. So that's one. Yes. So that one will be in the it will be in the, what they call it?
In capital letter.
Yes, it will be in capital letter. Yes. So in this context, they said A is a set of X such that X squared equals 4. All right. So the same thing, if I say that X is an element of A, I cannot say set X is a set of A. No. X is an element of A. Ma?
Yes. No, I get you.
Yes. If you say X is a set of A, you have failed it.
You have failed it.
But you can say
X has to be an element. It has to be a member of.
Yes. Yeah. So now the only numbers which when squared give us 4 are, so that means you need, for the mathematically, you have to solve this, because this one is a very simple something. That's why if it was to be a bigger figure, you can't just tell us the number by which you need to solve. So you need to solve for square roots. Okay, you need to find the square root of 4. All right, and the answer is what? 2 or minus 2. So 2 times 2 gives us 4. Minus 2 times minus 2. Minus times minus is plus, so it's still the same. Now that we have 2 and what? Minus 2 enclosed in a bracket, that is A. Then the second one said, so this one now is, you can read it as what? B is a set of X, or X is an element of B, such that X minus 2 gives us 5. So you need to find the number that when you subtract 2 from it to give you 5, and that will give you the set B. So you can see it said B is the set of X such that X minus 2 equals 5. The only known solution is 7, because 7 minus 2 gives us 5. So hence B is equals to 7, enclosed in a bracket. Is that clear?
Yes, it is very clear.
Then this one said they said this one now, C and X. So C is a set of X, or X is an element of C, such that X is what? Positive and X is also negative. And then we read it here, C is a set of X, so S is positive and S is negative. Now there is no number which is both positive and negative at the same time, hence C is empty. 0. So we can have, this is how to, so this one is empty set. And then we have here D is a set of X, or X an element of D, such that X is a letter in the word correct. So letters in the word correct, you can have C, O, R appear twice, so pick one. Then we have E, T appear twice, you have picked it before, then T. So you have to write it as I say. It reads D is a set of letters, set of X, sorry, such that S is a letter in the word. This is a word, not work. So is word. Okay, correct. Now the indicated letters are C, O, R, E, and T. Thus D is equals to
C-O-R-A-T.
Yes. But if we define a particular set by stating properties which its element must satisfy, for example, let B be the set of all even numbers, then we use a letter, usually X to represent an arbitrary element and right. Okay, so let's see. So this one. Now, what they are doing here is this. They did not really organize the material very, very well, but the messages are clear. So this one that we have seen above is what they call the rooster or tabular method is one. Now that they're trying to move to another one, which is the set builder. Now all this case now, um why I said that they did not really do a good organization is that I'm able to read these things in Word, interpret them because I have studied set builder. Some that have not studied set builder might not really be able to express this in words. So they should have. That is why in my own slide I started with the statement form. They started with statement form, and then from statement they will ask you to express. They will have given you statement, and they ask you to express that statement in tabular form. Then, from when you have understood tabular form, they now give you tabular form and ask you to express in set builder. So when they now know that, okay, fine, I've taught set builder, they can now express. That is when they can now give you these questions that they give here and now ask you to represent them in what tabular form. So it will really sink in. But most students are even lost because they don't understand this cell builder. Okay, there was nothing said about it, and then here we are. So some people would like, even when they look at the solution, they are still confused. Okay, which one is such as? What is this? How does it come about? Okay, and that is why somebody like me is needed to explain better. Now before we go to the next one, let's look at more examples and instances using the slides I created. So we have here the set of planets in our solar system. Okay, so this is a statement. Okay, so you cannot express them in what rooster form by listing them out. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. They close in your curly brackets. That is a very good example. Then we have set of SAARC nations. Okay, so these are all the nations in this particular group. Nepal, India, Pakistan, Afghanistan, Bhutan, Bangladesh, Maldives, Sri Lanka. Okay, and then set of colors of the rainbow. We have red, orange, yellow, green, blue, indigo, violet. So, simple and short. Okay. So this is a set of colors of the rainbow. It's been represented in a Venn diagram, trying to give you a taste of what's to come. All right, we are going to, look at that one much later. Then we have exercises. So here, say list the elements of the following set in rooster form. So the set of all positive integers, which are multiples of 7. So this is how, if you want to teach somebody rooster form of expressing a set, and when you have not actually giving them a hint of what set builder looks like, you start with this format. Okay, then when you know that they now understood and said, like this one, now this question is expressed in a set, this is a set builder notation. Okay, this question is expressed in set builder form, and they want to express in roster form. So you need to understand set builder. That's when you can be able to read and interpret this before you can now list them out in set builder, in roster form rather, or tabular form. Okay, list the elements of set in roster form. It said the set of all positive integers which are multiples of 7. Hello.
Hi.
We
So
are
So I'm listening. Talk to me. So talk to me.
14, 21, 49.
Yes, you need to start from 7 anyway. 7,
Okay,
then
so
14.
7, 14, 21, 49.
Yes, and also it's an infinite
Set.
um
It's an infinite number because it just keeps going and going.
so I mean that's just it. Okay.
And they will all be in the curly brackets and separated with comma.
Yes. Then we now have here the list the elements of the following set in a roster form. The set of all prime numbers less than 20.
Um, so that would be 2, 3, 5, 7, 11, 13, 17, and 19.
Okay, and then write the set of A, okay, such that A is a set of X and S is a natural number less than or equal to 8.
Natural numbers less than or equal to 8. Less than. 1, 2, 3, 4.
5, 6, 7, and 8.
You say less than 8.
Or equal to.
Yes, so from 1, 2, 3, 4, 5, 6, 7, and 8, yes. And then write the following sets in a roster form. A is a set of X such that X is an okay. This one is a bit complex. So S is an element of a natural number. Okay, and you know that is natural numbers. Now X is also like S is greater than 2 because I say 2 is less than X, and then S is less than equal to 10. So that is to say that S is A is a set of X, and S are natural numbers greater than 2, but less than or equal to 10.
Greater than 2
Yes.
will not be 3, 4, 5, 6, 7, 8, 9.
Um, Greater than 2, but it must be less than or equal to 10.
Less
And
than or equals to 10. So it will not be less than. It has to stop at 9 or equals to 10. No, it has to stop at 9 because they say less than 10.
or
Say less
equal to.
than or equal to. So it has to stop at 10. And then we have this one,
Oh,
write the following set in extra form. So X such that X is equals to 2 raised to power n, and n is natural, and n is less than or equals to 5. And this one I will need to explain to us. So here our solution. You can see we got this one correct. We got this, I think you did. So I have prime numbers, but it must not be more than 20. Once, yeah. Then we have
your address. You said Alaba Street.
Hello, sorry for that. It was these nasty bank people that calling me that they want to verify my account. Where do I stay? This one, that one. I coach people. Who am I coaching? All this kind of stuff. I don't understand. I don't know where this one is coming from. You should not try anything fun anyway. Are we there?
Yes, please.
Okay. So, it said you should write the following sets in a roster form. So we have x is an element of x is an element of A such that x is a natural number and x is greater than 2 but less than or equal to 10. So you can see that we got that correctly as well. Then for this one might be a bit challenging. That's why I said let me just explain straight off. Okay, so they said S is an element of X. So this one was, you can see now, I think I use this example in order to drive home the fact that we use capital letter to represent to name a set, and then the element with small letter. So you can see we have X here, both the capital and the small. So the capital is showing us that what this is the name of the set, and these are the elements. So X such that S is equals to 2 raised to power n. All right, 2 raised to power n, and these n are natural numbers, and the natural numbers must be less than or equal to 5. So natural numbers less than or equal to 5 are 1, 2, 3, 4. Since it is less than or equal to, so 5 must be
there.
That one is that. They said and so x will now be equals to s will be equals to 2n, that's 2 raised to power 1, or 2 raised to power 2. Do you understand? Or 2 raised to power 3, 2 raised to power 4, and 2 raised to power 5.
5.
Now said here that so now to find the elements in the given set, we need to apply the values 1, 2, 3, 4, 5 expressed between instead of n. So when we have 2 raised to power 1, okay, n raised to power 1 is the same thing as that number. Is it not true?
Yes, 2
So
times.
2, yes, so that is how we got 2 here. Then 2 raised to power 2. N raised to power 2, that means 2 times 2, right?
Yes, 4.
So 2 times 2. That's how we got 4. Then the same thing, 3. 2 raised to power 3. 2 times 2 times 2, that is 8.
2 times 4 times 2, 6.
No.
8. 2 times 2, 4 times 2, 8.
Then this 16 is the next one. 2 times 2 is power 4. That means 2 times 2, 4 times 2, 8 times 2, 16. And then 32. How did we get that? 2 raised to power 5. 2 times 2, 4 times 2, 8.
2 times 2, 5 times, which
So you
is
list
4.
them out.
Yes.
So 2, 4, 8, 16, 32. List them out. That's how you got that answer. Okay, these are the words, and you know you're expressing everything in rooster form. So all of them must be in commas, must be separated by commas, and must be enclosed in a curly bracket. So that's
Yes.
how we got our answer. Any questions on that? Is it clear? Are you
It's very,
confused?
no, I am not. It's very clear. Thank you.
You're welcome. Okay, so if any question was to come at all, if any question was to come out from this, we should be able to answer. Able to answer. Able to answer. Okay. All right. Now let's move on to the next one. Said here, set builder notation. Set builder notation. Set builder notation. Set builder notation. So we'll go to the next one after looking at the tabular form. Let's move to the set builder. So before that, let's see this. So here they gave us this. So B, and then open your brackets X, and then there's this vertical bar. X is even. It reads B is a set of X such that X is even, and we call this the set builder form of a set. Now notice that the vertical line, that is the vertical bar, is read such as. So in order to illustrate the use of the above notation, we rewrite the set in examples 1.1 to 1.10. So we note the set of A. Okay. So A, we have A. Hello.
Hi.
So they are trying to explain the set builder form. So they have explained that when you want to express it, you enclose in the bracket, but in this case you use you present the element by an unknown value. Use a symbol to represent it, and then you separate that with a vertical bar. Use a vertical bar to separate that and the rule. So the rule or the property with what is going to come afterwards, which is what in this case the X is what even.
Evil.
Okay, that's the rule. If X was to be odd, we have it here. X is odd. Okay, so let's say now to illustrate the use of the above notation, we will write the set in examples 1.1 to 1.10. That means those examples they gave us earlier. If you go back, let me scroll up. So all these examples, we're going to write it using set builder notation. Okay. So we have passed the place.
You need to go up a bit.
So they said the first one,
Evil.
this is the first one. So if you want to rewrite this, how do you do it? Anyway, so these ones that they did not really do a good job here. I believe there's a mistake on their part. So this one now is not expressed in set. This is expressed in what? In rooster form. If they want to express this, what they would have done is, hello, can you hear me?
Yes, I can hear you.
Could have said maybe A1. So is an element, is a set of X, sorry, such that maybe X is even. X is even. Okay. And then if you want to take it further, like we saw here, you can see, then comma this. So if you want to do that here as well, you can say X is even, then comma, say 0, 0 X, then X, and then includes it in your curly brackets. So this one is was set builder, because this is not a cell builder. So I don't know what they rewrite here. This one is okay. Okay, this one is correct. X is an element of A2 such that X squared plus 2. This one is okay. This one too is okay. This one, I should have just said X A, then A is a set of A, such A is a set of X such that X are vowels in the English alphabet. Okay, are we understanding?
Yes.
This one too. The same thing, they could have found a formula. Let's see what's the questions. Let's go back to the example. Said here the students, Tom, Dick, and Harry. Okay, so they should have just made it that S is a set of it's an element of
Students.
A5, I think. Yes, such that S are students. Maybe eight students, Tom, Dick, and Harry. Something like that. But what I'm trying to point out is that if it is a set builder, it must come in this form. There must be this bar. Okay, the other ways to represent, because this bar represents such as.
Such
In some
as.
cases, they can use something like this to represent it. In some, like
Okay.
what they could think, because this semicolon or column, something like this to represent the instead of having vertical
Like
bar, right? Yes, but that such as must be there, and then
when you
this
want to
side will be
present
the
a set builder, the socials must be there.
yes, and then the this side is the property or the rule. Okay, this side is the what, the representative of the what, of the elements. Then here we have the set. Very, very simple. So they have exercises for they said write this set in a set builder form. So they said let A consist of the letters A, B, C, D, and E. So if you want to make it set builder, that means it will be something like this.
A
You can see they say A
is
is a
equal
set
to
of X such
X,
that
X,
appears before F, okay, in the alphabet. So you can see now. Now let's go back. So this one now you need to reason. When you look at the elements,
a
okay, you
letter
can reason out
letter A
what is it, what do they have in common? What they have in common? So all of them appear before F. So you use that immediately to establish the common ground. Okay.
all
So
right.
S is one of the letters. So that means We are good for that with that. Okay. The next one, they said let B be 2, 4, 6, and 8. Okay. 2, 4, 6, and 8. So B is equals to X such that X is even and positive. Just as what I did above, you can see. So I was telling you that those ones we have here, all those ones like this one now, here is not set builder. So it's the same thing with what we have here, but I have to express it some other way. Now this one is infinite. Okay, that was why it stopped with S is even and positive. If it stopped at this 8, then there will have been comma and further explanation so that we know that it's not finite. Then let's see consists of countries in the United States of America. So X is an element of C such that X is a country, okay, and
X is in
X is the United Nations, okay. So if it's just a country, we might not just stop here because it's in United Nations. Yeah, there's another condition they gave. Maybe it's in the United Nations under this brand, maybe something.
that
There's
one
another
not
condition.
plus.
You put another comma, explain it, okay.
Okay.
Yes. Now I said letter let D be
Equals to
3.
3.
So D is is a set of X such that X minus 2 is equals to 1. So it is only 3 that when you minus it from 2 to give you 1. Is it not true?
Yes.
Yes. And there's another way to express it. If you come here, they made mistake here. Actually, this should be A is equals to X such that, so there'll be something here. The S is one of the first letters in the alphabet, yes. So one of the first, or you can say one of the first 5. Okay. Or you can say S is the 5. You can not even use one of. You can just say S is the first 5,
5 letters
like just
of
of
alphabet.
the alphabet. Yes, that's another example. Okay, so they say E is head of state, Obasanjo, Yar'Adua, and Jonathan. So X such that S was head of state after Abacha. So these ones are after Abacha. Okay, Obasanjo, Yar'Adua, Jonathan. Today we now have Buhari in the mix. So yes, now. So that's just it for that. And let's go to the slide I prepared. Let's see. So set builder notation is a mathematical shorthand where we state all the properties that are elements of the set. All elements of the set should possess. So what matters most is the properties. Okay. And then we have if you want to describe a set of numbers 1 to 7, we know that each number in the set should have the following properties. So these are the properties. It should be natural number. Its values should be greater than 0 and less than 8. These two properties are sufficient to describe each element of the set. They say if you want to describe a set of numbers between 1 to 7, that means that is 1, 2, 3, 4, 5, 6, 7. So you can say natural number is the first property. Okay. Then its value should be greater than 0 and less than 7. Okay, that's another
Less than 8.
property. So less than 8, sorry, because 7 is part of it. And these two
Yeah.
properties are sufficient to describe each element of the set. Now, the mathematical formula or notation so formed that completely describe the set is termed as what set abstraction. So all the formula or notation that describes the set is known as what set abstraction. You can also call it set comprehension or definition of the set intention. This system is used by denoting the elements by x or any other variables. Then the variable is defined by the rule we created earlier. So where we have, so you can see in this case, look what I told you, instead of using horizontal bar, you can see column is being
The
used.
column 1
Yes. So here
still
now
means the
A
structure.
is, yes, so this one is an A is a set of X such that X is a what? Planet in the solar
Planet
system.
solar system.
So if you can be given, if you're not given these and asked to express in rooster form, you just list them. Then let us consider a set C comprising of the colors in the rainbow. So you can say C is a set of X such that X is a color in the rainbow, or the same thing, but the difference in the what? Horizontal bar and the column.
Column.
So see how to read. See how to read it. The set of, so A is a set of X such that X is what? Less than 2. This is how to read it. Simple. So the image, the way to read the set builder notation is set of X such that X has so and so properties. Okay. Then we have different symbols which we'll look at later. Real numbers, whole numbers, integers, everything. This was a taste of what to come. And there are exercises for us. So they said represent the following set in set builder form: sun, moon, Tuesday, Wednesday. So how do you do this? Can anybody tell me?
Those are days of the week.
Huh?
Days of the week.
Yes. Yes. So let's, maybe you can name it maybe X. Say X is equals to, or S is a set of what? Maybe X, another small x, such that S
Such
is
that
days of the week. Okay. The next
days
one.
of the week.
Okay. So what again? Represent the following set in a set builder form. So what will be this now? We have
So this one will
1
be
half.
1/3, 1/4.
No idea.
2/3.
Okay, let's look at the solution. So look at the solutions. This one, we got this one. S is a day in a week. Okay, so this one we got it correctly. Then this one, the denominators of our elements are 1, 2, 3, 4. Okay, so the set builder form is A is element of what?
X.
Is a set of A is a set of X
Elements.
such that X, yes, A is a set of X such that X
Will be such that X is equals to
1 over, okay. I think what you need to know is that all of them, their numerators are 1. So this is 1 over 1, 1 over 1, okay. 1
1 over
over
2,
2,
1 over
and you can
3,
see that,
1 over 4,
and
1
they are all
over
natural numbers. So it's such that S is equals to 1 over N, and N is a natural number. Okay. Because you know that it is continuous, so
yes.
it's a infinite
Yes.
rather. That's why they stopped here. If it
Finite
stopped
set.
here, they would have said, if let's say it stopped at 1 over 4, they would have not said
The
N
finite set.
is what? N is less than something and greater than something. I hope you understand.
Yes.
Let's say it stopped at 1 over 4. They'll say N is what? 1 is less. So N is greater than 1, but less than 4
less
or equal to 4. You know, yes, to
or
show
equals
that it is it has range, but because it is infinite, so it
set.
doesn't matter.
It has the
Yes,
command.
N can be held. Yes. Then they said here, the next could say write the following set in set builder form. The set of all positive even numbers. Okay, so the set of all positive even numbers is written as S is member of A such that X is a positive even number. Simple. Well, most of them are simple, but some will get you to think very well. Now, write the following set in set builder form. We have the set of all whole numbers less than 20.
20.
So you don't need to start listing them here. Just put it a whole number and S. So here you can see here. They said if it was whole numbers, not give condition less than 20, you will have just stopped here. But this condition less than 20 actually means that you need to go extra. Sometimes you will not use and, you just put comma and you explain. You just add. But this one, just add, they add and it's still cool. And then we have write the following set in a set builder form, the set of all positive numbers which are multiples of 3. So multiples of 3 means 3, 6, what again? Yes.
15.
So, and so on. But we are not listing them. So it's positive integer and it's a multiple of 3. And that's all that we need
So
to know.
set form is almost like the statement form.
This one is like statement form, yes, but this such as is the difference. So in statement form, you don't put such as. You
You
just write the...
so the set builder form is
And
like a, where you have to
You,
put the
and
sort.
then and in statement form, you don't all this one that we are doing here that you use symbols. You
Will
don't do
not
it in
be
statement form. Yes, in statement form, you just write
whole
whole
numbers.
numbers less than 20, and then you enclose it in your curly bracket. Simple. So this one will not be there. If you expect this on the statement form, just say whole numbers less than 20. This one now, positive integers which are multiples of 3. So
That's
they are
it.
still different. They are
Yes,
still
that's
different. We compare. So now look at the table to show. So you have n numbers greater than 5 and smaller than 10. So look at it on rooster form. 6,
all right.
7, blah blah. Then
Less
look at
than statement.
it,
All right. Yes, it's
x
as
such that
less than
x is what greater than 5 and less than. So that is just it.
10.
I see they are different. Nations having areas larger than Brazil. You have these are the list of countries that their land are larger than Brazil. There are about four of them, and C is what a set of S, and such that X is what area is an area of land which is greater than area of Brazil. Okay, so you can this way you can also do it like this. C
It's equals to
is equals to open your curly bracket X. So let me just
X,
say such as
such
okay
as
S X okay yes such as X is greater
area. Okay,
than
it's
area
greater
of Brazil.
than area of Brazil. All right.
Yes. Then we have top 5 longest rivers in the world. That is the statement. And then these are the top 5 longest rivers in the world: Nile, Amazon, Yazoo, Mississippi,
In the
Yenisei.
table,
Yes, so that's why X is a member
such
of R, such that X is a river among the top 5 longest
longest.
rivers in the world. So you can see that they are all similar and connected, yet
Yeah.
different. So that will be it for today. Hope we have learned something
It
very,
was
very wonderful.
yes, we did. We did. Maybe I should. Or is
Thank you.
there's no more class work from that other one? From all those your other
There
ones,
should be
so that I can use
for the
to.
course material.
Okay, it's on the course material. To practice
I think the
the
course material has. I
statements,
think let me check. Let
tabular,
me.
and the set builder.
Okay, if there's none in the course material, I'll get some for you.
Okay, that would be lovely. Thank you so much.
You're welcome. So let me see. I think okay, there are some questions here. They said we write the following statement using notation. So you can try your hands on this.
Where are they?
Your course material page
Okay, okay,
29.
okay. 29. I've seen it. All right, no problem.
So, but I'll still get more questions for you later.
Okay,
So
so
that will be it
I'll
for
try
today.
these ones and send to you. Thank you, boss.
You're
Thank.
welcome.
Okay.
Okay, so that just can someone pray for us so that we can call it a day? Need
In
to.
Jesus' name,
Amen.
Father in heaven, we thank you for this class that we have listened to and we have watched. We thank you for the understanding. We thank you for the clarification. Papa in heaven, we pray that every other person that will come in contact with this video and this recording, they will receive also what we have gained from it in the name of Jesus. Thank you, Ancient
Amen.
of Days, for the vessel that you have used to put forth this tutorial. Papa God, continue to increase him in good health and in wealth in the name of Jesus. Thank you for it.
Amen.
Continue to bless our
Thank you.
going out and prosper the works of our hands. In Jesus' name I pray.
Amen.
Amen.
Amen and amen.
Okay,
Okay, till tomorrow. Bye bye.